So in this video, we're looking at the uniform distribution. And the uniform distribution is a distribution that also is sometimes called the rectangular distribution, because that's the shape that it makes if you were to draw it. Okay, so in a uniform distribution, it basically means that every single event, for a start, the distribution is continuous. Okay, so therefore it's been measured. And the only information they're going to give you is a minimum and a maximum. And hopefully they will tell you that every event are equally likely. But they may not. They may just tell you the minimum and the maximum. So imagine this situation is the one that we're working. Okay, I catch a bus to work. The bus is between 5 minutes early and 10 minutes late. So therefore, if it's 5 minutes early, that's minus 5 minutes. If it's 10 minutes late, that's 10 minutes. Okay, so I'm treating the minus numbers are early. You could have just made that whole width 15 minutes because up to 5 minutes it's early, and after 5 minutes it's late. I mean, really up to you how you work that out. Okay, but that's what I've done for my picture. So I know it's a little bit naughty that I've got my y-axis not going through 0, but I don't care because it's a sketch. And let's be honest, we're all big enough to cope with that. So on the formula sheet, they give you this. So this tells me that the height of my density function is given to me by a formula. So this height going across here is 1 over 15. Doesn't matter how you work it out, my minimum is minus 5, so A is minus 5, and my maximum is 10, so there you go. 10 minus minus 5 is 15. If I treated it at 0 and 15, or whatever other numbers you chose to use, my interval is still 15 wide, therefore my height is 1/15. Okay, now I've been asked to work out the probability it is more than 1 minute early. So at this point, we have to just be really careful. If it is more than 1 minute early, then I'm after that bit. Yeah, the bit bigger than 1 minute early, which is between -1 and -5 on my picture. Now, the only other thing that we haven't talked about so far is that the area is the probability. And this is the same whenever I do any continuous distribution. Doesn't matter whether it's a normal distribution, a uniform distribution, or a triangular distribution, the area is the probability. So the area of a rectangle is base times height. So I've worked out the height, it's 1/15. So when I come to work out the probability more than 1 minute early, I need to do base times height. Well, my base is the distance from -5 to -1, which in my case is 4. And my height is 1/15. So therefore my probability of being more than 4 minutes early, so being 1 minute early, is 4/15. And that's all you have to do. Now, working out the probability is not likely to get you any more than just an achieved. justifying the use of a particular distribution could get you up to merit on this, but I cannot see how they're going to get much more than a merit possibly out of a uniform distribution. It's such a simple calculation, given the fact that you have to do far harder things for less marks or achieve marks in this standard. I really think it's unlikely you're going to get so much out of this, but given the fact that how easy it is, everyone should be able to get these marks. Okay, so that's the uniform distribution. I'll do the triangle distribution next. You have a good rest of your day.